This is the linear regression quiz review worksheet. Remember, you can pause this video at any time and rewind it and go back and listen to it again if I'm going too fast. Which table best represents a linear model? So if you want to find the best linear model, you're looking for the R value to be 1 or -1. That means it is a perfect linear correlation, okay? So to find the R value, remember we put it in Desmos. So I've put in the first table. So I'm putting in 1, 2, 3, 4, and then I'm putting in 5, 8, 10, and 11. Then I have to do Y1 tilde, and this is linear, so it's mx1 plus b. And if you scroll right here, the R value is 0.98 is what it rounds to, 0.98. So I'll just go ahead and write that one down. It may be the best one, but we're going to keep going. So I don't need to delete anything. I just need to change these. Now I'm typing in answer choice B, and I'm going to look at the R value for this one. The R value for this one is 0.95. So I definitely know that's not the answer because 0.98 is closer to 1. All right, now I'm going to type in C. If you notice, C is not 1, 2, 3, 4, so I'm going to have to do all the numbers. 4, 6, 8, and 11, 2, 3, 4, and 5. And my R value for this one is 0.99, which means I know now A is not the answer. And for D, I'm going to do 5, 6, 8, and 12, -3, -5, -9, -17. And my R value for this one is -1. So the answer is D. Since it's -1, that means it's going down, but it's a perfect correlation. Number 2, there were originally 10 bushes in Mitchell's nursery. Each year, the Mitchells planted the same number of bushes. In the 18th year, there were 280 bushes. Which function can be used to determine the number of bushes in the nursery in a particular year? Remember, when we see the word originally, that means the starting value. And what number goes with the starting value? 0. So it's 0 and 10. And then after 18 years, there were 280 bushes. And if you look at your answer choices, they just want the equation that you get from those numbers. So let's put those in Desmos. So 0 and 18 and 10 and 280. And I scroll down. And they tell me that M is 15. M is 15 and B is 10. So the equation for that would be Y equals 15x plus 10. M is 10, that's your slope. I'm sorry, M is 15, that's your slope. So your slope is 15 and your Y-intercept is 10. Number 3, which residual plot indicates that the linear model is a good fit? So when you're looking at residuals and you want linear, you actually want it to be completely scattered. You're not looking for a straight line when you're looking at residual plots. You're looking at completely scattered. So the one that's completely scattered is the middle one. Number 4, a spring stretches linearly as the weight is added. The table shows data collected for a certain spring. How much does the spring stretch for each gram of weight added? So the question's asking, how much does the spring stretch for each gram of weight? So remember, for each gram would mean that you would put an X with the number, which means that you're looking for the slope. The number with the X is your slope. So let's see if we can find these slopes. Let's put this table in Desmos and let Desmos find the slope for us. So I am putting in 100, 500, 800, 900, 1200. Then I'm putting in 0.5, 2.5, 4, 4.5, and 6. And I'm looking for the slope, which is letter M. So let's look in Desmo, see what we get for M. We get 0.005. So what we're going to do is we're going to type 0.005. Sorry, let's look first at our answer choices. Is 0.005 an answer choice? No, it is not. All the answers are in fractions. So Desmos will turn it into a fraction. You just have to type it in again and hit the fraction circle. You get 1 over 200, which is A. Number 5, the table below shows the cost for visits of different lengths by cleaning companies in town. The length of a visit is represented by X. The cost of a visit is represented by Y. Each cleaning company charges a flat fee for visiting the house or apartment at an hourly rate. Based on a linear model, what is the best approximation of the correlation coefficient? Correlation coefficient is your R value. So once again, you need to type it in Desmos to find your R value. So we have 2, 2, 3, 3.5, 4, 4.5, and 5.5. Then on the other side, we have 72, 76, 91, 103, 105, 113, and 135. All right, and you just scroll down. The R value is 0.9925. The R value is 0.9925. Number 6, the table shows the average rate of change and the amount of years that it, let me start over. Number 6, the table shows the average height of a tree and the amount of years it has been growing. What is the average rate of change and the height of a tree from year 1 to year 5? So keyword, rate of change. We've done this problem several times. The formula for rate of change is y minus y over x minus x. Years are your x values. That's time. So your x values are 1 and 5. And so you're going to look in the table this time for your y values. Your y values would be 3 and 9. You'll just look in the table and then you will type in your formula. Remember, use parentheses. 3 minus 9 divided by 1 minus 5, and you get 1.5, which is C. Number 7, over the weekend, Bill played 10 games of bowling and recorded the following scores. According to the line of best fit, approximately what would Bill's scores be if he were to play an 11th game? Okay, so let's put our table in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 136, 142, 160, 151, 217, 163, 135, 142, 149, and 150. According to line of best fit, so line of best fit, well, we have to tell Desmos to do that. I had X'd it out, so I'm going to come down here and do another one. Y1 tilde mx1 plus b. And it wants to know, the question's asking, what would his score be if you were to play an 11th game? Well, look up here in the table. Is game X or Y? Game is X. So X equals 11. X equals 11. Before I can type that in, though, I have to actually type the function in. Y equals, you're going to put your slope, negative 0.10303x plus 155.067. I'm putting in the slope and the y-intercept from right above it. And then I'm going to put in x equals 11. And I'm going to find where they cross. I'm looking for a green and a purple. His score would be 153.9, which rounds to 154. We compared the y-intercept of the graph of the function y equals, or f of x equals 2x plus 3 to the y-intercept of the graph of the linear function that includes the points in the tables below. What is the difference? That means I'm going to be subtracting when the y-intercept of g of x is subtracted from the y-intercept of f of x. So difference means to subtract. The y-intercept of g of x, well, g of x is the table, so I'm going to have to use Desmos again. So let me put in a table. And see how it made them x2, so I need to make it x1 and y1. All right, so I've got 3, 6, 9, and 12, 20, 35, 50, and 65. And to find the y-intercept, I'm going to have to click over here, and the y-intercept is where it crosses the y-axis, so it crosses it at 5. So the y-intercept of g of x is 5. Now I need to find the y-intercept of f of x. Well, I can do that one without Desmos. I know the y-intercept is 3, and you're subtracting from it. 5 from 3. If you take away $5 for somebody who has $3, they owe you $2. Number 9, a caterer charges a setup fee and amount per person to provide a buffet. What is the caterer's setup fee? So a caterer charges a setup fee and an amount per person. Well, per person would be an x with it, so that would be your slope. So that means the setup fee is your y-intercept. So let's put it in Desmos to get our y-intercept. 30, 50, 70, delete that one. 350, 550, 750. And so I'm going to click over here to find the y-intercept, and the y-intercept is 50. The y-intercept is 50. Number 10, what does the y-intercept represent? Well, if you look at your answer choices, they don't have numbers, so I don't need to use Desmos. I just have to think through it. I'm looking for the y-intercept. Remember, the other word for y-intercept is starting value. So y-intercept has nothing to do with the maximum. The y-intercept also does not tell you whether it increases or decreases. That is slope. Slope would be decrease or increase. The y-intercept tells you the number of chirps when the temperature is 0, because your y-intercept is always 0 and then a number. Number 11, the line of best fit for a scatter plot is y equals 9.2x minus 0.9. The actual value of y when x is 12 is 115. What is the residual value? Residual is observed minus predicted. Observed minus predicted. Well, what do you observe when x is 12? They're telling you that when x is 12, then you get 115. So that's what you see. You see that you get 115. To predict, you have to plug 12 into the formula. You got to plug 12 into the formula. So I'm plugging in 9.2 times 12 minus 0.9. The predicted value is 109.5. And then I have to subtract those. 115 minus 109.5, and so you get the answer to be 5.5. Number 12 is asking for the difference. So again, you have to subtract between the observed and the predicted. So observed, again, is what you see. So for 7 hours, you see that it is 90. And so to get the prediction, you have to use Desmos. So to put this one in, 6, 7, 8, 4, and 6. 71, 90, 82, 26, and 55. And I'm going to do y1 tilde mx1 plus b, and that's going to give me my y equals formula. So I'm going to do y equals 15.5909x minus 31.